Today we're on pages 64 and 65 of our textbook, solving systems of linear equations. A system of equations is two or more equations with the same variables. To solve a system means to find the value of each variable that makes all equations true. We'll first be solving what is called a 2-by-2 system of equations, where we have two equations with two unknowns. We have the equation 3x plus 2y equals -9 and 2x plus y equals -7. So two equations with two unknown variables. And we wish to express our answer in x comma y form. What we want to do is we want to get our variable terms to be opposites. Now by opposites, I mean, let's say if we have a 3x, the opposite of 3x would be -3x. The opposite of 2x would be -2x. The opposite of positive y would be -y, right? So we want to choose one of our variables, either the x or the y in this case, and we want to make them so that they are opposites. So if I'm looking at my y's, I have a 2y and a 1y. All I need to do is take this second equation and multiply by -2, and then I would have opposite y terms. So that's what I'm going to do. I'm going to put a -2 out in front of the second equation, and I'm going to multiply every single term by -2. So this becomes -4x minus 2y equals +14. And just bring over the first equation, writing it right above it. So now we have these two equations, and our y terms are opposites. So now we would add these two equations. 3x and -4x is -1x. The y's drop out, and -9 and 14 is 5. Finish solving for x, dividing by -1. We have x is equal to -5. That is just our x value. Now we have to go and find our y value. You can go back to either equation, the first or the second. I'm going to go back to the second, original. So we have 2x plus y equals -7. I'm going to substitute -5 in for our x value. -10 plus y equals -7. Add 10 to both sides. You don't have to show this step. And we have y equals 3. X value -5. Y value +3. So this is our answer. I'm going to hold off on circling it until I check it. So to check, you go back to the original equations. I'm putting -5 in for x, so I have 3 times -5 plus 2 times putting 3 in for y equals -9. That's -15 plus 6, yeah, -9 equals -9. That checks. And now the second equation, original. 2 times -5 plus 3, does that equal -7? -10 plus 3, yes, -7 equals -7. That checks. So this is our answer. And we know it's correct because it checked in both original equations. Okay, now you had practice with this in Algebra 1, solving 2-by-2 system of equations. Well, here in Algebra 2, we're stepping it up a notch. We are solving 3-by-3 system of equations. So if we look in exercise 2 here, we have 3 equations with 3 unknowns, 3 variables, x, y, and z. So the steps for solving a 3-by-3 system of equations. The first thing we're going to do is label the equations A, B, and C, which that is already done for us, right? It's already done for us here in exercise 2. Next, we choose a variable to eliminate, right? We want to choose a variable to eliminate, okay? So we look at our x's. We've got a 2x, 6x, and -4x. None of these are opposites. So let's go on to our y's. We have a 1y, negative 3y, and 4y. None of these are opposites. So looking at our z's last, we have a 1z, a negative 1z, and a negative 1z. So we definitely go with eliminating the z's. So we're eliminating the z's. We're going to, I always add, we're going to add two sets of two equations producing two equations, labeling them D and E. Okay. So we're going to, I'm going to start with A and B, right? Because A and B, our Z's are already opposite. So I'm going to write down A and B, 2x plus y plus z equals 15, 6x minus 3y minus z equals 35. These are already opposites. These terms, these terms are already opposites, so now I'm just going to add. And the result is going to be labeled D, 8x, positive 1y and negative 3y is negative 2y, z's drop out, equals 50. Now, we already used A and B. That was one of our set of two equations. So now we have to use C. So I'll start with C. I'll put it here. C is negative 4x plus 4y minus z equals negative 14. And we have a negative z. So let's bring in A, because that has a positive z, so they're opposites. So we're adding C and A, because the z terms there are opposites, and the z term will drop out. Negative 4x, and this is going to be labeled E. So this is our second one, this is E, the result of adding A and C. So this is negative 2x plus 5y equals 1. Next, solve equations D and E as a system to get one variable answer. Okay, so here we are. We want to look at D and E. So now this is taking us to what we did back in number 1. We've got two equations, D and E, and two unknowns. So let's look at our x terms. We've got an 8x and a negative 2x. Oh, I like that. All I need to do is multiply this by 4, and that'll give me a negative 8x. Or we look at our y terms, a negative 2y and a positive 5y. Now I would have to maybe make this a negative 10y and this a positive 10y. In that case, I'd have to multiply each equation by something. So I'm going to eliminate the x's. So what I'm going to do is simply take E and multiply it by 4. So right underneath D, I'm going to say 4E. It tells me I'm multiplying E by 4. So 4 times negative 2x is negative 8x. 4 times 5y is 10y. No, that'd be 20y. Sorry about that. What did I lose here? Y. Okay. So 4 times positive 5y is positive 20y, and 4 times 1 is 4. Now we add these two equations. The x's drop out, and we have 18y equals 54. Solving for y, dividing both sides by 18, and y equals 3. So now we finally have our first variable value. Okay, next step. Substitute into D or E to get the second variable answer. All right, so we're substituting into D or E. I'm going to go to D, replacing our y with 3. So we have 8x minus 2 times 3 equals 50. Solving this, add 6 to both sides, 8x equals 56. And divide by 8, x equals 7. Step 6, substitute back into one of the 3 original equations. We're substituting into A, B, or C to get the third. Okay. I'm going to A. A has 2x plus y plus z equals 15. Substituting, switching at me. 7 in for x, 2 times 7, 3 in for y, and we're finding the variable z. So 14 plus 3 is 17. Subtract 17 from both sides, and we get z is equal to -2. And we will write our solution in what we call extended ratio form, which would be x comma y comma z. X is 7, y is 3, and z is -2. Now, before I circle the answer, I'm going to check, but I'm going to use the calculator to check. So for our check, sorry, I'm going to go over this way. I'm going to say a calc check. We're going to take 7 and store for x, 3 store for y, and -2 store for z. So 7 store for x, enter. 3 store for y. Alpha, number 1 is y. -2 store for alpha 2, right? Here's z right here. There was y. It's in green, so you have to press the alpha, green alpha. Alpha z, enter. And then I just type in the 3 original equations. So a 2x plus y plus z, 2x plus alpha 1 is for y, plus alpha 2 is for z, and it gave me 15. Alright, so I get 15, which checks. The first equation was 15, so A was 15, that checks. Do the same for equation B, 6x minus 3y minus z is 35, so B is 35, that checks. And C, -4x plus 4y minus z is -14. Awesome, so that's correct. So that is our solution. Okay, 2 more practice problems. Solve this system of equations. Express your answer in XYZ form. Check your answer. Which variable will be easiest to eliminate? Alright, so look at our x's. 4x, -2x, 5x, none of them are opposites. Our y's, we've got a 1y, a 4y, and a -1y. So we have one pair of y's that are opposites already. And our z's, no, they don't look good. So definitely our y's, it's easier to eliminate. So we're going to eliminate our y's to start with, and I will usually just put, I don't want to use that color, blue, eliminating the y's here, right? Okay, so let's label our equations, right? A, B, and C, and A and C are already opposites, so I'll start with those. Copy down A. 4x plus y minus 3z equals -6, and C right beneath it, 5x minus y minus 7z equals -19. These are opposites, so when we add them, the y's will drop out. Remember, we have our a, b, and c, so the result of adding a and c is going to be labeled d. 9x minus 10z equals negative 25. So we already used a and c, so now we have to use b. So let's look at b, and what do we have in b? Our y value, or y term, is a 4y. So let's match it up with c, and take c and multiply it by 4. So we'll have a 4y in b and a negative 4y in c. Alright, so that's what I'm doing next. I'm taking b as it is, negative 2x plus 4y plus 2z equals 38, and taking 4 times c, so 4c. 4 times 5x is 20x. 4 times negative y is negative 4y. 4 times negative 7z is a negative 28z. And 4 times negative 19 is negative 76. We add these, and this is going to be labeled E. So 18x minus 26z equals negative 38. We got some large numbers here, but okay, so now the next thing to do is to look at D. We're looking at D and E here, right? Looking at D and E, looking to eliminate one of the variables, and it looks like it would be easiest to eliminate the x's, right? If I just make this 9x, change it to a negative 18x, then these will be opposites. So we're taking negative 2 times d, so negative 2d, which would be negative 18x plus 20z equals 50. Let's bring over e. 18x minus 26z equals negative 38. Add these two, the x's drop out. We have negative 6z equals negative 12, no, positive 12. And divide by negative 6. Z equals negative 2. We finally have our first variable value. So now we go back to D or E, so kind of go backwards now. I'm going back to D here. So D is 9x minus 10 times z, putting the negative 2 in for z, equals negative 25. That's 9x plus 20 equals negative 25. Subtract 20 from both sides. We get 9x equals negative 45. Divide both sides by 9. X equals negative 5. Okay, so let me just circle that. I'll go back and circle this. Okay, so now we have two variables. Now we want to find our last one, y, so we have to go back to one of the originals. I'm going to go back to, I guess, A. 4 times negative 5, substituting negative 5 in for x, plus y, minus 3 times z, which is negative 2, equals negative 6. So this is negative 20 plus y plus 6 equals negative 6. That's y minus 14, these are like terms, equals negative 6. Add 14 and y equals 8. And I'll check this with the calculator. Okay, so x is negative 5, so negative 5 store as x, y is 8, 8 store as y, enter, and negative 2 store as z, enter. Okay, so I've got the three variables in there, their values. Now the original equation here, equations, 4x plus y minus 3z is negative 6. Oh good, that checks for A. For B, negative 2x plus 4y plus 2z. It's 38, good. And 5x minus y minus 7z. Negative 19. Good. Let's put this, our answer, in the form xyz, negative 5, 8, negative 2. Okay, we'll hold off and I'll do number 4, I think, or maybe, actually do this, if you don't mind, try 4 on your own. Maybe not. You can eliminate the x's, or you can eliminate the z's, would be the easiest. I would probably go with the x's. I think we'll hold off, that we're already 21 minutes into a video here, so I think I'll hold off and we'll do this tomorrow in class together. Thank you for your attention today.